Hello everyone, you're most welcome to Practical Physics course. Today we'll learn about the screw gauge and its use. So what is the purpose or aim of the screw gauge instrument? So using this instrument we can measure the diameter of the wire or thickness of a sheet or a beam, etc. So let's take a close look about the instrument first. So here we will discuss about the instrument details. Here you can see the real instrument and I will discuss different parts of this instrument. So this is known as the frame of the screw gauge. Here you will find a fixed end which is known as a stud, and there is a movable end which is known as a screw. This part is known as a sleeve, and over the sleeve you can see there is a scale, and each division of the scale is in millimeter. That means it is 0, this is 1 millimeter, this is 2 millimeter, and so on, and this is known as the linear scale. Here you will see at that part there is another scale which is known as the circular scale, and the total number of division is 100 here. This part is known as a thimble and this is known as the ratchet. So we will learn what is the purpose of this ratchet, circular scale, linear scale when we will measure some real data. Before going through measurement, let's take a look about the working formula of this instrument. So if you want to measure the diameter or the depth of an object using this instrument, this is the working formula. So for example, let's take that we want to measure the diameter of this pen. So how to measure that one? First we have to place properly this pen in between the stud and the screw. Then if we move in the right way at certain level, it will be well fitted in between the stud and the screw. At that time, so we have to make it tighten here. So at that time we have to take the linear scale data and the circular scale data. So we will discuss in details in the real time measurement. So for that moment, just focus on its working formula. So the diameter of this pen, it is the linear scale reading, that means we can take from here circular scale read plus circular scale reading into the least count of this instrument. Not only that, there is always a mechanical error of this instrument, so we have to subtract this error. So in this instrument there are two types of error, one is the positive error and another one is the negative error. Okay, so we will discuss in details about this also. So first, what is the least count here? Okay, so we will discuss first about the least count. So what is least count and how to find out this least count? So least count is the minimum length measured by the screw gauge. So how to find out this least count? For that we will use this formula, that least count is equal to the pitch divided by total number of division on the circular scale. So let's look at the instrument also. Okay, so then what is pitch here? So pitch means the distance moved by the screw when it is rotated through one complete rotation. So let's see it, what it means. So if I consider, so first I am making at certain position of my screw gauge, that means Let's focus it. Just observe carefully. In this linear scale, this line is known as the reference line, and at that moment the zero division of this circular reading or circular scale is matched with the reference line. Okay, at that moment, if I do a complete rotation of this circular scale, how much will be the movement along this linear scale is known as the pitch. So let's see it. At that moment you can see this is 0, 1, 2, 3, 4 and 5. So at the 5, the linear scale reading is 5 millimeter. So now I am rotating this screw for a single time. So now I am rotating this screw. So at that time, when I am just matching the zero of the circular scale with the reference line, you can see here. So how much distance traveled along this linear direction? Now count that one. This is 1, 2, 3 and 4. So you cannot observe this 4 because this edge is completely over this, the fourth division in the linear scale. So that means before one rotation the reading was in this linear scale was 5 and now this reading is 4. So how much displacements are there? There is a 1 millimeter displacement, and this is nothing but the pitch here. So we can write the reading for pitch P is equal to 1 millimeter. Now what is the least count? Least count is pitch divided by total number of division. Here total number of division in is equal to 100, right? You can see here also there are from 0 to 100. I can show you, this is the 0, and for the total number of division this is 90, 95 and again it is 100. So there is a 100 number of division. Hence the least count becomes, this is 1 millimeter divided by 100. Therefore it becomes 0.01 millimeter. So least count for this screw gauge is 0.01 millimeter. That means using this screw gauge we can measure the minimum of 0.01 millimeter, and less than that measurement we cannot measure using this screw gauge. So minimum accurate measurement of this instrument is 0.01 millimeter. Okay, so now let's see how to take this linear scale reading. So here it is written, to find out the linear scale reading which is marked on the linear scale which lies close to the left edge of the circular scale. So let's take an example. So right now we want to find out the diameter of this pin. So first I am inserting this pin, and now I am rotating the screw to tight this pin, right, and I am rotating this sachet that there is no further movement of this screw. So if you find this type of sound, that means it is well fitted in between the stud and the screw. So right now take the data for linear scale reading, and here try to count this division in the linear scale up to this edge of the circular scale. So find out where this circular scale is matched, this edge of the circular scale is matched with the linear scale. So this is 1, 2, 3, 4, 5, 6 and it is very close to the 7. So here we can take this is 7 millimeter linear scale, or we can write this is 7 millimeter. Okay. Now how to take the circular scale reading? The circular scale reading is the division of circular scale which coincides with the reference line. So let's check which reading in this circular scale coincide with the reference line. So if you observe carefully, you will find that this is 80, this is 85, so almost 88, this is 89, the 89th division is coincide with the reference line. So the circular scale reading will be 89. Hence we can write here the circular scale reading is 89. Okay. Now very important parameter when you are using this screw gauge is its error, which is known as the zero error. So let's try to understand what do you mean by the zero error of this instrument. To find out any instrumental error, so before measurement, first you have to rotate your screw properly, by which the screw completely touch the stud of the instrument. So I am rotating the screw, and at that point you can see, you can also hear the sound when I am rotating this ratchet. That means screw right now will not move further. So at that time you have to look at the circular scale and you have to find out the zero reading of the circular scale. So you can see that this is the zero reading, and where is the reference line? This is the reference line. So if zero reading of the circular scale does not coincide with the reference line, at that situation where screw is completely touched with the stud, then we can say there is a zero error. So in your device, if you find when it is closed completely, but here you can see it is not closed completely. So if any instrument, if you find that the zero of the circular is coincide with the reference line, then we can say there is no zero error. But when I am tightening this screw, at that moment the zero of this circular reading does not coincide with the reference line. Hence in this instrument there must be a zero error. So let's try to understand with this picture clearly. So there are three possibilities with your instrument. First, if you tight your screw with the stud, that means in the closed condition before measurement, if the zero of the circular division coincide with the reference line properly, then we can say there is no zero error. There is the second possibility, when the zero is below this reference line. So you can see right now the division, fifth division coincide with the reference line, and where is the zero? Zero is below this reference line. So what is the condition? In this condition, when screw touched completely the stud, okay, before measurement. So at this time you can see zero is below this reference line, and we call it as the positive zero error. So what will be the reading for this error? For that you have to count which division from 0, which division coincide with the reference line. So here error we can write it is E, and which is positive right now because 0 is below the reference line. And which division coincide with the reference line? You can see 1, 2, 3, 4 and 5. Always count from the 0. So this is the 5, and what will be the reading for that? Then multiply with the least count of this instrument. So what is the least count? We have found out it is 0.01. Hence the reading it is in millimeter. So here the error is 0.05 millimeter. There may be a third condition where you can see that 0 is above the reference line. Okay, so this is the case in our instrument also. You can see that this is the reference line, but its 0 is above the reference line. So how to find out the error? And this error is known as the negative 0 error. Here also you should count from the 0 to the reference line. You will find 1, 2, 3, 4, 5. So hence error is 5 division of the circular scale into the least count, that is 0.01 millimeter, but in this situation it will be minus. So it is minus 0.05 millimeter. But you should very careful that you should not take that which division coincide with the reference line. That means you cannot take this 95 is my negative error. You always have to count from the 0, 1, 2, 3, 4 and 5. So this is the negative error. But in our real instrument, if we observe carefully, we can find out. So let's take a close look. So there is clearly a negative error. And what is the error for that case? From 0 count, this is 5, this is 10 and this is 15 and this is 16. So in this instrument you can find out the error is 16. So error we can write error, and which is the negative error. So 16 division of the circular scale coincide with the reference line. So and multiply with its least count, then and this will be in your millimeter. So it is minus 0.16 millimeter. So in this instrument that much negative error present. Okay. So now move to the real measurement. So this is the table to measure the diameter of a pen. So here we will use this pen to measure the diameter of this pen. Okay. So this is the table. We can take 3 different data for 3 different position over this pen: linear scale reading, circular scale reading, and the diameter D is equal to linear scale plus circular scale into least count. Then we will take the mean D and the corrected diameter, that means the mean diameter minus the error. So always you have to subtract the error with its proper sign. Okay, what we have found out error here? Error is equal to minus 0.16 millimeter. So our corrected D, let's say it is D prime, it will be D minus of 0.16 millimeter. So that means D plus 0.16 millimeter. It will be our final result. So let's start the measurement. So first open your screw and place properly this pin. Now tight this screw, and you should take very careful measurement. Now I am rotating the ratchet. Yes, it is properly closed. Now take the reading for the linear scale first. So you can see the linear scale reading, it is 1, 2, 3, 4, 5, 6 and 7. So the linear scale reading is 7 millimeter. And check the circular scale reading, which deviation coincide with the reference line, and you can see you always take the clockwise direction. That means it is 80, this is 85, 86, 87, and in my opinion it is 88. So the circular scale reading is 88. Okay. So take 2 more reading, then we will complete our calculation. So again we can change the position. So let's open it, and I am changing the position of this pen, and it is completely tight right now. Again take the linear, it is 7, and obviously there will be no change in this linear scale. So here you can write it is again 7 millimeter, and check about the circular scale reading. Maybe there is a little change or may not be. So try to, this is 85, 6, 87. Right now I found this is 87. Okay, take another position, and I am making careful measurement right now, you can see, and it is completely tight. Okay, and you can again see the linear scale is 7. So it is again 7, and let's check about the circular scale reading, and it is near about 80, 81, it is 81. Okay, so now complete the table and find out the final result. So the first reading is equal to linear scale reading is 7 plus 88 into 0.01, which is in millimeter. So it is 7 plus 0.88, and you can see it is 7.88. Okay, here similarly it is 7.87 and it is 7.81, and let's do the average for that. So the average becomes 7.88 plus 7.87 plus 7.81, which is 23.56 divided by 3, and it is approximately up to 3 significant digit. This is 7.85. So what is the corrected value? Then we have found out here negative error, so the error must be added with this result. So 7.85 plus 0.16, which is 8.01. So the corrected diameter of our pen is 8.01. So this is the use of screw gauge. Even we can measure the thin wire, diameter of the thin wire using this instrument. So that's all for the day. Hope it could help you, and we will next present another experiment which is known as the Young modulus. Thank you.